In this chapter, we are going to talk about the transaction processing and the concurrency control mechanism of the databases. DBMS follows strict rules of creating transactions and executing them in a way that it doesn't leave the database in an inconsistent state. Hence, the knowledge about the transactions and how they execute and how they may create some problem to the databases is very important to understand. This chapter talks about all those scenarios. Before we start understanding how the transactions are carried out in the database management system, it is very important to understand the following terms. The term single user system means that at most one user at a time can use the system. A multi user system implies that many users can access the system at the same time. We use a special term called as concurrently or concurrent access to tell that many users can access the system in the same time. Concurrency or working on many users working on a same system can be done in two ways: interleave processing or in by using parallel processing. It is known as interleave processing when concurrent execution of processes are interleaved in a single CPU. It means that a single CPU is running more than one transaction at a time, and these transactions are interleaving or they are using the CPU time one at a time. For example, transaction one works, then the transaction two stops working for some time until T1 finishes. So it is like an interleave fashion. So whenever the transaction gets the CPU time, it executes. Here we have a single CPU. This is called as interleave processing. Parallel processing. Here we have multiple CPUs, and hence here we have multiple CPUs. Hence, processes or transactions can be executed in the same time using this multiple CPUs. Hence, we have covered three important terms: single user system, multi user system, and concurrency. There are again two types of concurrencies: interleaved processing and parallel processing. Interleaved processing uses single CPU, parallel processing uses multiple CPUs to carry out the processes. Now, a very important slide, and it is a for sure question if you are going for an interview to become a database administrator or any of the DB related job. The ACID properties of transactions is very important to understand. ACID stands for atomicity, consistency, isolation, and durability. A for atomicity, C for consistency, I for isolation, D for durability. Atomicity. A transaction is atomic. It means it is a single unit of processing. It cannot be again made into pieces. So we cannot cut a transaction. The transaction is a single atomic unit. It completely works or it may not work at all. So there is no way of executing half transaction now and tomorrow you execute or sometime later you execute the remaining half. No, it cannot be done. It is a single unit. This is very important term. It is atomic unit of processing. It means it is a single atomic unit. It cannot be divided further. It is perform in its entirety or not perform at all. This is very important. It means the transaction will run completely or it will not run at all. Consistency preservation means a correct execution of the transaction must take the database from one consistent state to another consistent state. It means the database was working properly in the morning. You have executed transaction one, then from one, the execution of this transaction should bring your database from the previous state to the new state in the consistent manner. It shouldn't be like that. Before executing the transaction, the database was consistent. The values were correct in the values of the data items were correct. But after executing T1, the values of the database have become inconsistent. In such a case, the transaction is aborted. It means the transaction is cancelled and the transaction will roll back. And it will again, it must ensure that, or it will ensure that the database is in the consistent state after executing itself. This is called as consistency preservation. Isolation. A transaction should make its updates visible to other transactions The transaction should not make its update visible to other transactions until it is committed. It means like the transaction T1 is working on some data item X. So while it is working on data item X, this value of X should not be visible to transaction 2 or other transactions until and unless the T1 commits. This property enforces strictly, if this property is enforced strictly, it will solve the temporary update problem. So there is a problem called as temporary update problem that we will see shortly. Okay, and makes the cascading rollback transactions unnecessary. So there is a problem called as temporary update for which we need to, do certain strategies to avoid this problem or to solve this problem. One of them is called as cascading rollbacks. So it says that if the isolation is strictly followed, there will be no problem of temporary update and cascading rollbacks can thus be avoided. The last one, durability, also called as permanency. What does it mean? It means that once a transaction changes the database and the changes are saved, we use the term committed in the transactions, right? To save. For example, whenever I want to save, I will say the transaction has been committed. So committed means saving it. Okay, hafat, once a transaction changes a database, the changes are committed. These changes must never be lost with the subsequent failure of the disk or the system. So it means that once the transaction have executed correctly, the values of the data items on which it worked should now be committed to the disk and it shouldn't be lost because of subsequent failure or upcoming failure. Next slide. Now, what is transaction? A transaction, as we said, it is a logical unit of database processing that includes one or more access operations. A transaction will have one or more access operations inside it. For example, read or write. Now, what is read? Read means retrieving a value out of a database. Writing means inserting or updating a value, or even deleting a value is called as write. So, a transaction can have more than one read or write operations inside or in combination. One or more access operations will be there in a transaction. We will see one example shortly. Uh, For example, here is a transaction T2, which is reading item X and writing item X after making some modifications inside it. This is a simple transaction, how it looks like. A transaction T has some access operations inside it. For example, reading and writing are the two access operations and one manipulation, which is changing the value of X or updating the value of X. So here we have three access operations, read, update, and write. Okay, here we have another transaction which is having more access operations inside it. So, transaction may be standalone, specified in a high-level language like SQL, interactive, submitted interactivity. Sorry, a transaction is a set of operations, as we said. Okay, and it may be standalone, which can be written in SQL, submitted queries, or may be embedded within a program. So it can be a simple SQL statements that you write to perform certain actions together as a group can become a transaction, or it can be inside a program to do this work for you. Transaction boundaries are there. It means a transaction every time begins, and after doing all the work, it ends the transaction. So, begin and end. So, are the 2 points. Begin is the starting point of the transaction. After doing all the work, then the transaction ends. So we will also see the different states of transactions between the begin and the end of it. An application program may contain several transactions separated by begin and end transaction boundaries. So an application program will have several transactions inside it for sure, and each one of them are separated by their beginning and the ending of transactions boundaries. Simple model of database. Uh, Now, the model of the database is given uh, by the granularity. It means the granularity of the data means a field inside the table or a record inside the table or a whole disk block. Okay, so the concepts are independent of granularity. Whatever concepts we are learning, it will apply to field or record or the whole disk block. They are independent of the granularity. A database itself is a collection of named data items, or it is a collection of logically related data, as you have studied in the database concepts. Basic operations that can come inside a transaction can be read transaction or write transaction. When we say read underscore item X, it means the transaction is reading the value of item X. To simplify our notation, we assume that the program variable is also named as X. Okay. Write item X means writing the value of the program variable X into the database item named X. So read X means it is like you are trying to read a value out of the disk block or from the memory. Writing means you are trying to write the value inside the variable X, which you stored inside the disk or in the main memory. So, read and write operations. The basic unit of transfer, read and write operations. Basic unit of data transfer from the disk to the main memory. How do you transfer the data? We know that we transfer the data from the disk to the memory in the form of one block, right? This is called as block transfer also, right? Block access also from the disk to the main memory. In general, a data item is read or written will be the field of some record in the database, although it may be larger units such as a record or even a whole block. It can be. It is just simply meaning that the basic unit of data transfer is a block that you read from the disk into the main memory. Now, this block can have whole database inside it or a part of a database inside it or some records or fields. Okay. Reading the item X includes the following three steps. If you want to read the item, if you want to read the value of the item X, you have to perform three operations. Finding what to read, copying that into the disk block. Okay, copying that from the disk block into the main memory by using a buffer, and then copying item X from the buffer to the program variable named X. Yeah, please stop this video for 1 minute and read these three lines. Then I will explain. Okay, so it means that if you want to read item X, yes, you need to find the address where the X is stored. If you want to access, if you want to come and meet me in my office, you need to find out my office address. Similarly, if you want to read X, you need to find the address of X. Where does the X, is written? It is written inside the disk block. So you need to find the address of the disk block. Simple. After you find the address of the disk block, you copy that disk block into a buffer inside main memory. If that disk block is not already in the same in some main memory buffer, then you copy it like this. So it's like, we are trying to read X. We need to find out the disk block which is holding X. Once you get that, you copy the disk block inside the main memory. If it is not there already in the main memory, then you copy it. Otherwise, you don't copy it. How do you copy? By using a buffer. Okay. Copy, then what? Then copy the item X from the buffer to the program variable named X. Then you transfer the value from the buffer into the program variable X. Okay, so this is called as reading item X. Writing X. Now, we need to find the address of the disk block that contain X, then read it and store and update the block from the buffer to this access. Now, if you see here, the point 2 and the point 3 is same as we have done in the reading process. So it is the additional thing what you have to do is after you read, you just do one more thing. What is that one more thing? Store the updated block from the buffer back to the disk. It can be done immediately or sometime later. So it's like, reading is just reading through for example, take an example of you reading something and writing something. In reading, your eyes will read and you stop. In writing, you read and then you write. Exactly the same process in the transaction write also. You perform the read operation first, and then after the read operation is performed, this is the read operation only, 1, 2, 3 points. Then you store the updated block from the buffer back to the disk. So it's like, from the buffer, you made some changes and then back you are writing it to the disk. So this is the additional thing. This writing can be done immediately or sometime later. So this is called as immediate commit or commit later. It's like saving immediately or saving later. Okay. Here two sample transactions are given that we have discussed already. Introduction to transaction processing. When we have multiple transactions working, it is very important to control them. How do you do that? And why do we do that? For example, why the concurrency control is needed. If for example, you have two transactions or 10 transactions running simultaneously, it can create some problems. Okay, it can create some problems. Just a minute. It can create some problem. Okay, I just wanted to remove the extra thing from incorrect summary problem right now because I want you to understand the problems, the number of problems here. The concurrency control is needed to avoid the following problems. How many problems are there? If the concurrency control is not taken care, there will be three problems. The lost update, the temporary update, also called as the dirty read, and the third one is incorrect summary problem. How many are there? There are three. What are they? Lost update, second one temporary update, and third one incorrect summary problem. The temporary update or is also called as dirty read. Now let's see what are they. Yeah, please take a look at these two images that we have it here. These two images that we have it here. Okay. What are we doing here? We have a dirty read problem. There is transaction 1, there is transaction 2. T1 is reading and then writing, but it did not commit. And T1 started reading A and wrote or write the item A into the memory, into the disk, and then committed. But later on, T1 wrote these values, but it failed. So this is called as dirty read. So T2 transaction 2 tried to read the values made by transaction 1. However, it did this before T1 even committed. And because it did not commit, it it failed and we did not have any copy of it. For example, here we have transaction 1 and transaction 2. T1 is reading A is equal to 100, then it made A is equal to 90, and then it wrote the value of data item A as 90. But did you see it? The T1 did not commit D. T1 did not save the value of item A. Okay. Now T2 read the value as 90, made some changes, and then wrote the changes and then committed. But originally, then later on, T1 failed. So the original values of so the T1, T2 is operating on something made by T1, but the T1 failed. It's like you took a decision based on your friend decision and your friend backed up. So you are dangling. You don't have any original decision with you. Okay. So this occurs when one transaction updates a database item and then the transaction fails for some reason. Okay. We will see what are the reasons later on. The updated item is accessed by another transaction before it is changed back to its original value. So it's like T1 made the changes of A to 90, then it failed. So the value of A will be 100, but T is reading it as 90 because T2 read the value of A before T1 committed and T1 failed in this case. So the value of data item A is different for T1 and it is different for T2 now. For A it is 100. For T1 A is 100. For T2 A is 80 now. So which is wrong? Okay. So this is called as a dirty read problem. The lost update. The lost update is happens when this occurs when two transactions that access the same database item have their operations interleave in a way that makes the value of some database item incorrect. For example, you have transaction A and transaction B, and then you have a data item X. Transaction A reads the value of X and changes it. It says X is equal to X plus 15. Now, A read X as 100, made it as 115. Now, transaction B read X and subtracted 25 from it. So, you see, A has read the value of X as 100, made it as 115, but it did not write. Because it did not write, B read it as original 100 only. But what is the actual value? A made it as 115, but B is reading as 100. Why? Because A did not save it. And B, A changed it, but it did not inform about the change. So B doesn't know the change. So it is reading the original value as 100. Then B made it at 75. And then B wrote it as 75. Now, after a long time, A is transaction A is saving it as 115 and B is saving it as 75. You see, now the database will be in the inconsistent state because the data item X is different here. The data item X is having a different value here. This problem is called as the lost update because the update was not informed and another transaction read it differently. Did you get the point? This is called as lost update problem. The incorrect summary. The incorrect summary happens when we have a transaction who is trying to calculate an aggregate summary function on number of records. While doing this aggregation or addition or subtraction or some kind of aggregate function, the transactions are reading the items values before reading for some of them and after updating for some of them. Okay, for example, the example could be grade calculation out of 60 marks done on some students whose grades were updated and for other students whose grades were not updated. Now you can easily relate this problem. When we give you the grades out of 60, if you have your midterm exam or quiz 1 or quiz 2 or project, with some, grading mistake that you went to the teacher and she increased your grade. Okay, so the update. So, this update, this updated grades are not considered for you, and for other students it was considered. So this is called as incorrect aggregate summary function done on some students before the grades were updated and for some other students after the grades were updated. So this is called as incorrect summary problem. Okay, we have an example for it. For example, we have transaction T1 and T2. T1 is reading X and making changes X minus N. Before it wrote T2 again, so this is the lost update. So we don't want to discuss, we discussed it already. Already done. Yeah, this is the some incorrect summary problem. T1 and T3. Transaction T1, T3 started calculating the sum. It read the item A, sum is equal to sum plus A. Okay. And meanwhile, transaction T2 is trying to read item X. X is equal to something. Okay. X is equal to X minus N and then write the item X. Then reading T3 is reading item X and adding X into the sum and reading Y and adding Y into the sum. Okay, now you have read T3 reads X after N is subtracted and reads N before reads Y before N is added to it. So T1 is making changes to item X and item Y. T3 is taking this value, adding it. So T3 took the value of X after subtraction. So this is the latest value it took. For Y, it did not take the latest value, it is taking the older value. So X was updated, the aggregate is correctly calculated for it. Y was not updated, however, it was taken. Okay, it was taken for it into the accumulation. So I hope you got the point. We have talked about three types of problems wherein we need the concurrency control. What were they? The first one is what is the first one? Let's go to the slide. Yeah, the first one is last update. then temporary update, and the incorrect summary. Okay.